In this video, we are interfacing LCD to PIC microcontroller. First, we need 16F887 PIC microcontroller and configure it at 4 MHz clock, an internal oscillator and RE3 pin as digital input-output pin. Now, I am taking a LCD. LCD is a output device. Here a LCD. Going to external properties, you can see there the size of the LCD. It is wrote as 16x2, means there is 16 row and 2 column. Many more types of LCD are there, as 16x1, 16x4, 20x1, 8x1, 40x2. There's many more LCD are there, but we need 16x2 LCD. Is a standard LCD, and there is a text size that is not important. After that, text color and background color, these are not important here, and important is the size of the LCD. Now take a infinite loop. In the infinite loop, we are taking a component macro. In component macro, there is a LCD here, and there are many more options in the LCD. To run the LCD, first we need to start the LCD. So we choose the start macro first. Okay. Now take another component macro here. I'm taking here write a string number. So we choose print string. In the string, we are writing anything in between double inverted comma. It will show in the LCD. This LCD are alphanumeric LCD. Means it can show numeric value, it can show symbols, also it can show letter. After that, take some delay of 500 millisecond. Okay, now run it. You can show the hello world is written here. After that, I am save this file to an location and compile it to a hex file to see the output in real life. And save it. After save it, it will compile to hex file. Wait until it is finished. Now the compilation is finished, and close the window. Now open Proteus. In Proteus, and select schematic capture. In schematic capture, I am taking the microcontroller. It is 16F887. Now I am taking LCD. There is many more types of LCD are there. I am choose 16x2 alphanumeric LCD. Okay. Now place the microcontroller and place the LCD. See here, LCD have many more types of pin here there. We am connect the pin. Now go to Proteus and see the connection. There is data 1, 2, 3, 4 are there, and RS and enable. They are connected in port B. Data 1, 2, 3, 4 is in the LCD D4, D5, D6 and D7. Now RS is connected. After that enable is connected in port V5. Okay, go to Proteus. Enable is connected to port V5. Data 1 is connected in port V0. Data 1 means D4. It is connecting in port V0. After that data 2 is connecting port V1, data 3 port V2 and data 4 port V3. And I'm connecting respectively. Now here VDD and VDD, VEE and RW are connected to ground. So I'm connect VDD to the ground, VEE to the ground and RW to the ground. And VDD is connected to VCC, power source. And D0, D1, D2 and D3 is not connected. It will be open. Now take the hex file here and change the clock frequency at 4 MHz and find the hex file and put the hex file in the microcontroller. Now run this. When I run it, you can see hello world is printed in there. Now I am changed something. So go to Proteus, go to FlowCode. And delete this code first. And start macro is transferred to after begin. It is outside the infinite loop. And there is another component. I'm set the cursor. Thus X position and Y position. X position is row position, Y position is column position. Row position is 0 to 15 and column position 0 and 1. So position is 3 and 1. See the hello world is written in second line and it is changed the position. I'm compiling to hex file and show in Proteus. It will change the position or not in Proteus. Go to Proteus and run it. You can see it will change the position. Okay. Now I'm changed something. I'm write some number here like 1 2 3 4. If number is shown in the LCD, and check it in Proteus. First we have to compile it in. Because the LCD is called the alphanumeric LCD, the number can show the LCD. So I'm check if a number is shown or not. Go to Proteus and I run it. The number is shown. So letter also shown, number also shown. In FlowCode also number is shown. I'm change something. I'm take in between space their number and check space is shown or not, and take another cursor position. It is x0 and y0, and take another component macro after that. In this position I am wrote another things. In this position I am wrote some symbols are there. See, symbols are written or not. After I run it, here the symbol is shown and number also shown after a between a gap. Now compile to hex file and shown in a Proteus. Okay, finished. Go to Proteus and run it. In Proteus you can see the symbol and number and space, they both are shown in the LCD. So in the LCD, number, symbol and letter, all things are shown here. Now I am delete all things in the FlowCode and create a new FlowCode here. The new flowchart. Now I am print some number. I'm taking a variable first. There is an integer types of variable. The name of the variable is a and initial value is 0. Okay, I'm print this number of the variable value. After that, taking a delay of 1 second. After that, there is a calculation. What is the calculation? In the calculation I am increment the number, that is a is equal to a plus 1. So number is incrementing 1 by 1. Now all are okay. When I am run it, you can see 0 after 1 after 2 after 3 and go on. 10, 11, 12. After the 13, 14, 15, 16 go on the LCD. Now after some number it will down to the second line in 25, 26, 27, 28, 29. So 13 to 24 gone outside the LCD. See what happened in Proteus. First compile to hex file. Go to Proteus and run it. There's 0, 1, 2, 3, 4, 5, 6 and wrote the number. This is very much slow. I change the delay. I change the delay 1 second to 500 milliseconds now. After compilation done, so compilation needed. After compilation, go to Proteus and see what happened next. Now Proteus, the number is in writing 10, 11, 12. After 13, it is not shown. See, in 25, it will shown or not in second line. Waiting, waiting. Waiting sometimes. See, there is 37, 38, 39 is shown. In real life, the another things are shown. This 13 to 36 is not shown in the LCD. Now, I am change something here. Now I am change something. Let's set the cursor position. And set the cursor position at 0, 0. Now see what happened here. In same position, number will be increasing. The number is increasing at the same position. Okay. See what happened in Proteus. Compile it. Finished. Now go to Proteus and see what happened. The number is incrementing in same position now. Now I'm changing something in this program. I'm take some input a switch. Go to the external properties. I'm take a push button switch and it is momentary switch. Okay. Now when I press the switch, the number is incrementing. Let's see what happened. First, when I read the switch, to read a switch to a variable, to create a new variable, and name this variable is SW and initial value is 0. I am read the switch variable to the SW. Now I am checking the SW variable. It is 1 or not. So if SW equals to 1, if it is 1, then it is the perform this operation. If it is 0, then show only the value of the variable a. Okay, now run it. See what happened. 0, 0, 0, 0, 0, 0. When I press the switch, it is 1, 1, 1, 1, 1, 1, 1. Why? Because I am not create a cursor position if switch is not pressed. So I am take a component macro here to set the cursor position. And take the cursor position same as if switch is 1. So now this is 0. When I press it is 1 and I press it is 2. When time press, it is 3 and it is incrementing. It is compiled to hex now. In Proteus, I am taking a button and a resistance. Therefore, taking a register. Okay. Now place a button and resistance to make a switch connection. Here button, resistance, button and resistance connecting in series, and resistance to the VCC, and button and then ground. In between button and resistance, the switch is connected. The switch is connected at port A0. In between button and resistance, I am connecting to port A0 pin. Okay. Now see, when I run it, it is initially 0. When I press, the value is increment, and I press, the value is increment another time. When I press the switch, the value is increment. Now go to the flow code and take another switch. This switch is decrement the number. This is also a push button switch and it is also momentary switch. Okay. Now in second switch, first we read the second switch. Read the second switch and create a new variable. So name of this variable is SW1. Initial value is 0. If second switch is pressed, the value is stored in SW1. If first switch is not pressed, then check if second switch is pressed or not. If then second switch is pressed, means if SW1 equals to 1. Then what happened? Then it will decrement. Means first when set the cursor value of the LCD at 00 position, then print the number, that is A, the variable A, print the number. After that, taking something delay, after that a calculation. It is decrementation calculation. A is equal to A minus 1. If it is no, then only show the value of the variable A. Okay. Now I'm run it and see what happened. Oh, switch connection is not done. Second switch connection I have not done here. So go to the second switch, create connection. It is unconnected. So I'm connected in port A, say 1. Port A1 pin. When I press first switch, the number is incrementing. When I press second switch, the number is decrementing. Decrementing to 0. After I press, it will goes to -1, -2, -3, and so on. In LCD, the minus value also shown. An incrementation switch, the number is incrementing. Check in Proteus, it will happen or not. So compile to hex and go to the Proteus. Okay, finished. I'm close the window now. I'm go to the Proteus. Taking a second switch here. Where the second switch is placed. Okay, here. And taking a resistance here. Connect switch and resistance. The resistance connected to VCC and switch to ground. In between switch and resistance, a wire taking to the port A1. Now run it. When I press the first switch, number is increment. When I press the second switch, number is decrement. Again, after 0, it will show -1, -2, -3, and so on. It is the importance of LCD over 7-segment display. In 7-segment display, the minus value not shown. Okay, thank you.